I'm going to start by explaining one of the easier, in quotes, easier ones. I'm going to start by explaining 10, and then I'll get to 11. I'm going to do 10. I'm not going to do all of them, but I'm going to do some of them, 10, 11, 13, and then I will do these three because they're ugly.
So really you're
okay.
not doing two of them?
So I'm not doing three of them. So number 10 says, use function machine G, use G, okay? Put -1 inside of G and see what comes out. So again, that says G of -1. It says put -1 in G and see what comes out. So function G says this: G of x equals x minus 2x squared. So we need to put -1 inside of function G and see what happens. The way we put it inside of it, if you notice that -1 is right here, x is right there, that's the thing that changes in that statement. So in this part of the statement, we need to take this whole set, and every time there's an x, we're going to replace it with -1, because that's just how they work. That's where we put them in. -1 is the input in the function G, so we're going to put it in where the inputs go, in the x spot. So we're going to get G of -1 is going to be -1 minus 2 times -1 squared. Okay, we put those in parentheses just for emphasis because it's a negative. The -1, this -1 is just kind of standalone. 2, -1 squared is +1, so it just kind of sits there. -1 times -1 is +1, and then we do the multiplying. -2 times 1 is -2, and we drop that like it's hot. -1 minus -2 is going to be -3. Okay, so G of -1 equals -3. That's our final statement you can write. What that just says, this final statement says, machine G, when you put -1 inside machine G, it churns out and it cranks out -3. Okay? And the way that it cranked it out is we looked inside the machine. This is the rule of what happens. We did -1 minus 2 times -1 squared. Okay, and we put it in. So we're going to turn around and do 11 for you guys. We're going to squeeze it up here. 11 says put -1/3 inside of G. Okay, -1/3 is the input. That goes in for x. So x -1/3 minus 2 times -1/3 squared. Okay, that's how we put it in. We put it in spots where there are x's. -1/3, nothing gets done to that right now. And then here we do -1/3 squared, which is going to be 1/9. Okay. -2 times 1/9, positive 1/9. We're just going to rewrite that as -2/9. -2 times 1/9 is -2/9. And then we go ahead and add those, and that'll be -5/9. Does that help? Does that help? Okay, let's do 13. Let's step it up one notch. Number 13 says we take -3, we put it in rule G, or function G, or machine G. Okay, we see what happens after we put -3 inside the machine, and then at the end we'll add 13 to it. That's what this says before we even start. So what we want to do is we want to take -3, put it in G, and then at the very end, we're going to add 13 to it. Okay, so we're evaluating function G for -3. So we get -3 minus 2, -3 squared is 9. Okay, -2 times 9 is -18. -3 minus 18 is going to be -21. So it's -8. Guys okay? Come at me if that's not okay if you were here yesterday. If you were not here yesterday, this is probably not okay to you. Okay, now let's do 14. What? Yes. Okay, 14 says take function f, machine f, and put inside of it h plus 9. Okay, that's weird. But that's just what we just need to commit to that. Commit to the fact that all we're doing is putting h plus 9 inside f, inside rule f or machine f, where it goes. Okay, so on f, we have f of x, and our x is there. Instead of x now, we have an x plus 9. We're going to take that and put it in the spot where x is. Okay, that's how we put it inside the machine. It goes in the spot where the variable is. So we're going to do 2 times h plus 9 minus 6. Okay, so again, what 14 says is take function f, put h plus 9 inside of it, and see what happens. See what comes out. We're going to crank it out. So distribute that, 2h plus 18 minus 6, 2h plus 12. And that is as simple as you get. That's as simplified as it gets. I'm not implying that that question was simple, okay? That wasn't what my intent was on that comment. I was like, wow, that could be interpreted different. No, I'm saying that that's as simplified as the final answer gets. You cannot simplify any further. When we do 15, we're using function g, and we're putting in 3y inside of function g. So in function g for x, we're going to replace it with a 3y. So we're going to take 3y minus 2 times 3y squared. And then we're going to simplify it if we can. So we get 3y minus 2 times 3y squared is going to be 9y squared. If you don't know how to do that step, that's not a huge deal because you won't be tested on that particular spot, just so you know. And then we're going to multiply that by 2. The important thing is being able to write this on this problem for us. Okay, writing that first step is the thing I really wanted you to think about. Yes.
So you keep the squared?
Number 16 says, if you read it, it says take rule G, put B inside of rule G, or machine G, or function G, put B inside of function G, okay, put B inside of function G, then add 1 to whatever that is, and at the very end multiply the whole thing by 2. Can you get that logically, those steps, before we even start? So we're going to take 2 times whatever we get from putting B in to function G, okay, and then we're going to add 1 times it by 2. So let's put B inside function G. So we're going to get B minus 2B squared. B goes in place of x. It's just B, so it looks the same except that it's a B instead of an x. And now we can't simplify anything on the inside, so what we need to do is just distribute. And that's an appropriate answer. I would most prefer this. That's a minus sign, by the way. I would most prefer that. That's a minus sign, even though it's squiggly. Okay, if we look at J, great job in class, guys. Most of us worked the whole time and focused right at understanding this. That's fantastic. If we look at J, we need to take it apart into pieces. Before we even start, we need to get an understanding of what's actually going on in the setup of the problem before we start diving into it and just making stuff up if we feel like we have issues. So we're going to step back, we're going to look at it all together, then we're going to go into it. First, J says, take function G, take 4, stick it in function G, and get a number, right? That's what that says. G of 4 says take 4, stick it into G, and get a number. You guys still show some maturity and stop goofing around right now? So we're short on time. We're going to take 4, stick it in G, and see what happens. Okay? We get a number. We're going to then add that to 2. Okay? And at the tail end, we're going to add that to taking negative 10, sticking in F and whatever we get from that number. So essentially what I did it off to the side. I found what G of 4 was first, because I wanted to simplify the writing. So I found out what G was for. That was a number 48. Okay. I found out what F of negative 10 was. So I put negative 10 inside F, and I got 23. Put that on the outside. Now we're going to do the 48 plus 2, and then in the end, plus 23. Okay. We're just breaking it apart into pieces as we go. Okay, on this page, if you got to it, okay, it says right ordered pairs to represent where X is the years, school year since 0405. Okay, if we're talking about the school year since 0405, 0405 will then be 0 because it is 0 years. 0405 is 0 years since 0405. Okay, so 0405 is actually 0. Then 0506 is 1 year after that, so that then becomes 1, and then 2, and then 3. So we get order pairs 0, 1, 2, 3. Okay, we graph it. I need to talk to you about things that make this graph correct after you graph it. Okay, so this conversation is really important for you, especially if you hadn't gotten here. So look up and listen. Okay, everybody come with me here. First, your x-axis is your independent variable. That is your time, typically. Our time is school years since 0405. So we need specifically to say that on our x-axis if we have the context. So that has to be written out, that whole thing. Otherwise, it's just not right. Okay. Our y-axis, our dependent variable, is the enrollment in 1,000s, in sets of 1,000s. So that has to be there. The units have to be represented there on the y as well. Also, we need to try to fill up most of the graph by the information. If you ever don't start at 0, you need to represent that by breaking the graph. Okay? This blue squiggly line that I wrote on the bottom left, that's me saying the graph is broken, it's not starting at 0. Okay? You have to do that to represent that we're not starting at 0. We plot the points in this situation. We actually do not connect it in this case. Okay? We do not connect it in this case because in this context we're talking about total enrollment for each year. There's no year 1.5 after 0405. Does that make sense? There is no year in between 0405 and 0506. So we cannot connect them because there's nothing happening in there. Does that make sense? Okay. Okay, let's go. Let me show you the other one. And let's talk about the last one. You're expected to be able to do this stuff on your homework and all that type of stuff. So in this case, in the last one, we actually do want to connect the dots because you could be, in the context of this, you could park for 2.5 hours. You could park for 2 hours and 2 minutes if you wanted. They're supposed to be connected, so in this case, it's a yes at the final question. Yes, it should be connected. Here's the deal. For your homework, guys, if you didn't get to these graphs, that's fine, but what's not fine is you not finishing them. Okay, and you not checking your work. So I expect you to go home, if you didn't get to these, I expect you to go home, take a look at the video, okay, and pause the video and listen to the video so you make sure to understand how to make these graphs because you're going to be expected to do that, okay? Your homework is also listed on the website. Your homework is also listed on the website. I keep it. I don't want it. It's also listed right there. That help, Chris? Matt? So tonight, click on that book, and you'll get that.
Oh, sorry. No. No, I'm not. Not this time. I'm gonna catch up.
You do.